Hi folks, today I'm going to take you through exception handling in Python. And exception handling is kind of just a fancy way of saying error handling. So we're looking for things that will break your program and cause it to stop. And we're also looking at ways that we can handle those errors and give the user better input on what data they need to give you in order for your program to work. So we're not going to dive too deeply into this. We certainly do more of it in Computer Science 30. Up until this point, I've said for the programs that you submit to me, if you ask me for a certain piece of data in a certain format, I will give it to you. So I won't try to break your program. For instance, if you ask me to enter an integer less than 100, I will enter an integer less than 100 instead of trying to type hello there. But you can't count on users to give you proper data despite all your best efforts to tell them what you need. So that's why we need exception handling in Python. So there's a greater expectation, certainly at the 30 level and toward the end of the class here in the 20 level, that you'll build your programs to be a bit more sensitive to the errors that users will make and to build in exception handling to make sure your programs don't break when they give you bad data. So that's what we're doing here. I had a different PowerPoint up at first, but I decided I didn't like it very much. So I went and grabbed the start of a PowerPoint from Mohammed Sikander, and I added to it and subtracted from it and whatnot. So it's kind of a mishmash between the two of us. So here we go. So what we're going to handle in this, pardon the pun, exceptions, what they are, how we handle exceptions, the try and except blocks, which are just new commands and statements that you can use in Python, handling multiple exceptions or errors, handling multiple errors in a single except block, raising your own exceptions, and then there's something called the finally block that we can use. So we'll get right to it. So an exception, when writing a program, we encounter errors. It's going to happen. An error can be caused by improper program structure. Your program doesn't work for some reason, usually because of syntax or the commands. Maybe you've got a capital T where you don't need one, or you forgot a colon or a comma or something like that. Or there are also errors that are semantic errors, whereas your program won't necessarily break. It'll still run, but it won't give you the result that you're looking for. So we can use exception handling to deal with both of those types of errors. Errors also happen, they often happen at runtime. That is, usually the syntax errors, if there's something that's typed wrong in your program, it happens at runtime. So when you run the program, it will break right then and there. So here's a couple examples. They occur when, if we're trying to find a file rather, and the file isn't where it should be in the wrong folder or something like that. We can get a file not found error, or if we try to divide a number by 0, Python can't do that. No program can do that. So it's a zero division error. Whenever those types of errors occur, Python creates what's known as an exception object. It basically logs the error and says, this is the type of error I think it is. And if you don't handle those errors, it just stops your program and it prints you back a little message called the traceback that says, we can't run this program because of this error, and some details as to why it happened and maybe what line of your program it happened on. Okay, so here's an example of a program that'll cause an error. So I've got three variables, A, B, and C. A is 5, B is 2, and C is 0. If I try to print A divided by B, and then I try to print A divided by C, you'll notice that it's able to print A divided by B, but then when it tries to print A divided by C, well, C is 0. You can't divide by 0. It's an undefined number in mathematics, so my program breaks. Okay, and you've probably seen something like this before when you're building Python programs. Is you've made a mistake somewhere and your program doesn't run, so you get what's called a traceback. The traceback says, in this file, on this line, you tried to do this, and this is why we broke. It's a zero division error, division by 0. You can't divide by 0, it breaks Python. Okay, so the first statement runs properly. The second statement raises an exception, which is an error. And the traceback is Python telling you what the error is and where it is located. See, line 6. And it's trying to give you enough information to fix it. So to handle this, or to deal with this, we handle exceptions with code, usually using something called try and except. A try block contains code that might throw an exception. It might work, it might not work. So if that exception occurs, the code in the try block stops. It says, I can't do this because I'm going to raise an error. And then it skips over to the except block and the except block is the one that actually runs. If there's no error, the code in the except block doesn't run. It just runs the try block and moves on in your program. And they look kind of like if-else statements. They're coded kind of similarly. So I've got the same program here. I've got A, B, and C, 5, 2, and 0. This time I'm trying, so it's try, colon, and then indented, to print A divided by C, which I know is not going to work because it's an error, right? It's 5 divided by 0. So I want you to try to print A divided by C, but if you can't, okay, there's an exception that prints there's some problem with your code. Okay? So if it can do this, for instance, if I was trying to print A divided by B, it would be able to do that because it would get 2.5, so it would never run this except. But because I'm trying to print A divided by C, it can't do it because this is going to be dividing by 0. So it then stops the program right here and says, oh, I can't do that. And then it goes to the except and it says, okay, so I'm going to print there's some problem with your code, and then I'm going to move on with the program. So it checks the try, and it either runs it or it stops. If it stops, it runs the except. But it doesn't stop your program, right? So your program can keep going instead of raising that traceback error and halting everything. Okay. So the try block attempts to do something, the except block runs because the try block raised an error. The message we included indicated there was an error, but not what the error was. In this message, I was not specific. I didn't say why this occurred. I just said, hey, there's something wrong. Okay, now you can specify potential errors within your except block. There are all sorts of built-in errors or built-in traceback exceptions in Python, and one of them is actually called zero division error. And you have to type this in exactly perfectly, otherwise it won't work. So in this case, I tried to do the same thing. I tried to print the A divided by C, and this time I'm putting in a very specific error. It says except zero division error. So the only time this exception will run is if it is in fact a dividing by 0. So if I've got, like I try to divide Z by C and I don't have a Z, it's not going to run this because, mislabeling a variable or having some other type of error isn't going to run this except. The only way this except is going to run is if what you try to do up here raises this very specific error, which means you have to have tried to divide by 0. In this case, my message can be very specific, right? I'm printing, you can't divide by 0, because I know if I get the zero division error, I know that the whole problem was you can't divide by 0. It can't be anything else. So when I ran this program, you'll notice it didn't print anything for the try, but it did go to the except and it says you cannot divide by 0. So we're giving the user better feedback so that if they have to enter another number for C, say you've got an input statement for C and they keep putting in 0, they'll keep getting this error. And then eventually, if you've given them enough feedback, hopefully they're smart enough to not put a 0 in there. Now, you can have multiple different except blocks to handle different exceptions. The zero error, the zero division error was just one of them. There's hundreds of them. You're not going to use hundreds of them. You'll only use a few. But you need to know that you can deal with different types of errors in the same block, right? So do the same thing. Try to print A divided by C. Now I've got all sorts of different potential errors. If it's a name error, I'm going to print this variable does not exist. If it's a zero division error, I'll print out you cannot divide by 0. If it's type error, you cannot divide by a word. If it's a runtime error, I'll just say the program did not start for some reason. So we in this particular instance, we know from the previous example that this is a zero division error, but we can check these other 3, okay? But it's only going to run the one that it should. This arrow is actually pointing at the wrong thing. It says we checked, but it's none of these errors. Oh no, sorry, it is. I changed my C. It's not a zero division error. My mistake. It's not a zero division error. I changed C from 0 to high, the word. So it's trying to print A, which is 5. It's trying to print 5 divided by the word high. Well, it can't divide a number by a word. So it's not a name error. Everything's named properly. It's not a zero division error. We're not trying to divide by 0. It is a type error because the type for C is a string, and we can't divide numbers by words. So it's going to try to do this, and it's going to raise a specific error, and that error is going to be called type error. So it checks, and it goes, nope, it's not that one. Nope, it's not that one. Oh, okay, this is the error I raised. So it's going to print you cannot divide by a word. And it never actually gets to this runtime error, because as soon as it hits an except that works, it's just like an else statement or an if-else statement. If you've got if and then a bunch of elifs, it only runs one of those. It'll never run more than one. So it's only going to run one of these excepts, and it might run none of these excepts. Okay, in this case, it was a type error, so it'll run the type error exception, and it'll print you cannot divide by a word. And there it is. It's a type error because we tried to divide by a word. Okay, now you can also put multiple exceptions into a single block using parentheses, and basically have that except block handle similar type errors. So in this one, I'm trying to do the same thing. C is still high, it's still a string. And in this case, I'm trying to print 5 divided by high again. But this time I've grouped a bunch of these into one. So if it's a name error, a value error, or a type error, I'm going to print check your variables and data. So, these ones are kind of similar. They're not exactly the same, but they're kind of similar. So I grouped them all, and I said my input back to the user is just check your variables and your data for the type. I've got a 0 division error, which says you can't divide by 0, so it's not going to run that. And then I've got a runtime error that says the program did not start. Now, in this case, it's going to run this first one because I'm trying to divide 5 by the word, and that is indeed a type error because the data type for C is a string, and it needs to be an integer or a float. So it is actually going to run this first exception, and it's going to print out check your variables for and data for type. Okay, so it never is going to get to the 0 division or the runtime because it is indeed a type error. So the whole point of this is you can check for 3 different types of errors, or 4 or 5 or however many you want inside one line of code. Now you can create your own exceptions in any situation. So this is referred to as raising an exception. The situations that you use this for, your code may not, or the input may not cause the program to break and stop, but they may cause you some other logic-related problems in your code. I mean, if you wanted them to put in the number 5 and they put in number 10, it might not break your program, but it also might not give them the output that they need, or it might not give your program the input that it needs to run properly. So you can use that to raise your own exceptions and let the user know that you need something different. Now, you could also do this with if statements, but oftentimes if there's potential for your program to break completely, you'd want to use try and except as opposed to just using if statements. Okay? Because if you use an if statement and you don't handle all the potential errors, your program's going to break and your user's not going to be able to do anything anyway. So I've got a different program here. Let's say I've got x equals 4, and what I'm going to try to do is I've got an if statement inside my try. Remember, that's called nesting, when you put one statement inside another or one structure inside another. So inside my try, I'm going to do an if. If the type of x, that's x right there, is not an integer, I'm going to raise a type error. So by typing in raise space and then whatever error it is, you can tell the computer specifically, this is the type of error I want to raise if they screw something up here. And it could be whatever you want. I mean, this in particular is a type error, but you could raise a value error, or you could raise any type of error you want, as long as it is one of the built-in ones. In this case, I'm keeping it a type error. So if the type of x isn't an integer, although we can see it is, I want to raise a type error. And then it goes down to the elif. So if x is not equal to 5, I'm going to raise a value error. Okay, so I've got 2 different exceptions down here, one for the type error that I could possibly raise, and one for the value error that I could possibly raise. Now, if I run this program, x is 4 and it is an integer. So if type is not integer, well, it is an integer, so it's going to skip that to the elif, and then it's going to run the elif, and it's going to say, if x is not equal to 5, well, that is true, because 4 is not equal to 5. So because this elif statement is true, it's going to run what's below it, and what I ran below it was raise a value error. Okay, so because this line of code was true, I basically raised my hand and say, that's an error. It might, in this case, it's just standing in for an error. So I'm basically broadcasting there's an error, and this type of error. So now it goes down to the exceptions, and it says, no, it wasn't a type error that was raised, it was a value error. So it goes to the next one, and it says, oh, okay, it was a value error, so now I'm printing right data type, but not the correct integer. And that's what the program did when it ran. So again, ultimately, because x equals 4, I raise a value error, and my except block prints out what I asked it to print out. The point here was that I can raise errors, basically broadcast that there's an error whenever I want, only if I use the built-in error types. Okay, now you can't do custom exceptions until you study classes in Comp Sci 30. So until then, when you're raising exceptions from the ones built into Python, use the ones, or you will use ones that are built into Python, and here's the most common. And I see that when I converted my PowerPoint over, I lost some of my information. So I'll make sure that this slide is fixed. Common ones: index error, raised when you try to access a character or list item that does not exist. So for instance, if we were working with a string, and the string was A equals Python, if we wanted to access the first letter, the capital P, in Python, and we've seen this in many videos and examples before, we would know that we have to get the 0th element, right? Because 0 in computer science is really the beginning of whatever the string or list is. So we would have to access A square brackets 0 to isolate the P. But what if we tried to access something that wasn't there? So this is 0, 1, 2, 3, 4, 5. So there's only 5 index positions in the word Python. What if we tried to access 6? Okay? If we tried to access 6, our index is out of the range. It's higher than what's actually in that variable. So that's when you get an index error. And the same thing if you're trying to access something from a list. Say you've got a list that's got 3 things in it, and you try to access the 4th thing. There is no 4th thing, so it gives you an index error. Memory errors often happen if you've got a you're trying to store too much data. I mean, it's not going to happen much. Or if you run an infinite loop and your actual computer runs out of memory, so if you've got a situation where your program is looping and printing something infinitely and your program will not stop, eventually your computer runs out of memory for it and it'll shut down. So most of the Python IDEs are set to run for a while, and then if it thinks it's an infinite loop, it'll throw a memory error traceback. Name errors when you have a variable or you try to access a variable but you didn't create that variable. So let's say I had A equals high and B equals there, and then I tried to print out, print C. Well, I never created a C, so that's a name error. There was no variable named C. And then there's the type error where I mentioned that was when you got the wrong data type. You need a float and you didn't get one. You needed integer and you didn't get one. You needed a string and you didn't get one. You needed Boolean and you didn't get one. So those are quite common errors that you're going to see. There's also that 0 division error, which I think is hiding in here somewhere. And there's also a general runtime error, and it's just kind of the catch-all. It's just kind of like the one you use at the very end where it's like, it wasn't a specific error from the list of 50 or 100 errors or whatever is built into Python, but it still didn't work. So it's kind of like the catch-all error. So hopefully that gives you a little bit more information on how we can improve our programs. Speaking of the catch-all, finally is a command statement that you can use to make sure that some code runs no matter what. So a finally statement, it's placed at the bottom of a try except. So you can have try and maybe you got 5 excepts in there, and then at the end you can have a finally. If none of those 5 excepts worked, you can run a finally statement. The finally always runs. Even if the try runs, the finally will also run. So you got to be aware of that. It's not kind of a normal either or. It's going to do this or it's going to do that. Finally will always run, and it's just there to kind of keep your program going. I almost never use finally, but I wanted you to know that it exists. So here's an example. I've got x equals 4, and I'm going to try if the type of x is not an integer. Well, it is an integer, so it's not going to raise the type error. Because I didn't raise any errors, I did not raise this because this was false. So I didn't raise any errors, so none of these exceptions are going to run because I didn't raise an error and the program didn't raise an error. So at the end, I've got a finally print that says there's something wrong, I don't know what it is. So when I ran the program, it tried to do this. It couldn't do this, but it didn't raise an error, so it had nothing to compare it to. So it said, well, there was no error, so this except I'm not even looking for it. I'm not looking for this except either, or I'm looking for it and I didn't find it. And then finally, okay, so I get down to the finally and it says, well, there's something wrong. I don't know what it is. So it is kind of a catch-all. I tried a couple of error types. We still didn't know what was wrong, but we still gave the user some input, even if it was of limited value. So that's how you can use finally. Again, I don't use it very often. Why do we use it? I've explained it a couple times. You can prevent your program from breaking when someone enters data that doesn't match what you're looking for. Never underestimate the amount of errors people make with data entry. No matter how explicit your instructions are, they're going to screw it up. You're going to ask for a capital letter, they'll put in a lowercase letter. You're going to ask for an integer, they're going to put in a float or Boolean or something. So using exception handling allows us to build more bulletproof programs that people can't break, whether they're trying to do it on purpose or whether they're just being, they're just not reading properly and giving you bad data. Because there's nothing worse than you building a really nice program and then not sort of idiot proofing it, allowing your program to break because someone is not giving you the data that you need. So that's why we use it. Okay, now I did have some examples over here in in Thonny. But I think I went through most of these pretty well in the video. I would recommend that you just go with the PowerPoint and just go into Thonny or whatever IDE you're using, and give some of these a try. Give them a try, and see how they work. The one thing that I didn't have in my PowerPoint, the last thing I want to note is, usually when you are asking for input from a user, you want to give them an opportunity to put in a new answer or give you different input if they gave you the wrong input. So most of the programs that I went through in the video with the PowerPoint, it didn't have any looping. It didn't have any way for people to put different input in. It was just sort of, here's the input and now here's the errors. But if you're in actual practice, when you're trying to get input from a user and they give you bad data, you want to have a loop in there so they can try and do it again and again and again until they give you good data, right? So here's just an example of using a while statement and me, basically my program not giving up until I get what I want. I'll just clear all my data here. So the while true, and while true just means it's going to run until it's false. And I don't actually have to set it to be false anywhere. I can use the keyword break. And when the computer hits any break, whether it's in an if statement or a loop or anywhere, it's going to break out of that and just go to the next indent or non-indented line in your code. So a good way to start a loop, even if you don't know how to end it right away, is by using while true. Okay. Now you could make a while anything, right? You could be while x is less than 5, while a equals hi there. You could put any logic up here. But if I use while true, I know it's going to run. Okay, so the very first line, while true, it'll go in. It'll say, I'm going to try. Okay, so this is what I'm trying to do. X equals input, and my message to the user is type Jeff. So if X is not equal to Jeff, what I'm going to raise is a not Jeff. Okay, and that's basically just going to say not Jeff. Okay. Else, okay, the else means I did type Jeff, so it's going to break. Now, break doesn't mean break your program. Break means break out of the while. So if I do type in Jeff, it's going to break down here. It's going to print Jeff, and then it's going to print program over. Okay. If I raised an exception, okay, then it's going to go to the except, and it's going to print that is not Jeff. Try again. In fact, I don't need to raise this exception now that I think about it. That's kind of pointless. It's going to try to do this, and if I can't do this, it's going to go to the except. So when I run my program, it says, it doesn't like my else. If Jeff not equal to Jeff. Oh no, maybe I didn't use that right. Sorry. I had an if statement, but I didn't have anything happening if my if statement is correct. I mean, we're kind of used to seeing it down here, right? So I should put it there, raise not Jeff. So I'm just basically raising an error that says not Jeff. Okay, sorry, let's run that again there. So it says type Jeff. So I'm not going to type Jeff. I'm going to type ASDF. Then it says, because it goes down, it raises the error, it goes down to the accept. It says that's not Jeff. You want to try again? Okay, so it says, again, type Jeff. Well, no, I'm stubborn. I'm typing SDAF. So again, it tried to get me to type in Jeff, but I couldn't. So it raised an exception. And then to handle the exception, it said, that's not Jeff. Try again. Okay, well, now I'm not going to be as stubborn. I'm going to actually type in Jeff. And then it's going to say, okay, great. I tried this. And the third time I asked you, you finally gave me Jeff. So I was able to do this. Okay, X was, okay, the if statement says X is not Jeff. Well, it was, so it's not going to run that. It's going to go to the else. And the only thing under the else is break. So it's going to break out of the while to the next unindented line, which is print X. So it printed Jeff, and then it printed program over. You know, people aren't necessarily stubborn when they break your programs, but it could be something like this. Okay, it wants me to type Jeff with a capital J. Well, what if I type in Jeff with a lowercase j? Okay, it's not right. Okay, so it raised the error, and the exception said that's not Jeff with a capital letter. Right? Try again. Okay, so then it said type Jeff. Whoa. Okay, so that's a pretty, that's pretty reasonable error for someone to make. Is like you look at it, and you go, oh, I typed in lowercase j. Okay, so then I'll fix it. I'll put uppercase j, and then it runs. That's such a small error, and that's something that people could conceivably do. Do you really want your program to end and break because they used a small j instead of an uppercase j? I mean, no, that's a silly reason to have your program break. So if you build in some error handling like this, okay, your program doesn't break, and it gives the user an extra chance to put in the proper type of data and less frustration for everyone overall. So that's exceptions and exception handling in a nutshell. And hopefully, as we get closer to the end of the course, you can maybe use that a bit more in your programming to make it a bit more robust and bulletproof. All right, if you got any questions or if you need different examples or whatnot, feel free to email me. I'm always available for help.